Hi, my name's Andrew Caldwell. I'm an EDR specialist here at Fortinet in Canada, and I'd like to take a few minutes to give you a quick overview of FortiEDR. What you're looking at right now is the management console. This solution can be cloud hosted, fully GDPR compliant and hosted in your region, or it can be installed on-premise, or you could have it in your own cloud or in a hybrid situation. All features the same, exact same look and feel, whether in the cloud or on-premise. The extremely lightweight agent is installed on either Windows, Macintosh, or Linux endpoints. As you're looking at right now on this Windows 10 machine, the collector agent consumes approximately 60 megabytes of hard disk space, and in terms of memory, averages between 70 to 100 megabytes of RAM, give or take. This makes it one of the lightest EDR agents on the market today. From a protection point of view, what makes this solution truly unique is in the security policies. We'll have a look here, and you're going to see the 4 default policies that are included with FortiEDR. FortiEDR came through the acquisition of Ensilo last year. Ensilo had 4 to 5 different patents for kernel-based protection on the endpoint. This is significant. What this means is that there's kernel visibility into all processes, all applications running. Every single disk read-write, every single memory read-write, every single network access, every single registry access, etc. All processes are being interrogated through this patented method. If you consider other endpoint solutions, to get kernel visibility, what often is done is to take their DLLs and inject around commonly exploited processes. And while that method does work, what the challenge is that you can't do it to every single process because performance is an issue and or the DLL may interfere with that process. With kernel-based inspection, you're actually able to see absolutely every single running process, and that's what makes this solution truly unique. And that's also why this will run extremely well in an online environment as well as in a completely isolated offline environment. As there's no signatures, there's no IOC feed that's mandatory for protection. So let's see some of this in action. Let's start with the simplest of use cases, and that is malware being written to the disk. I have a zip file which I'll unzip which contains some commonly known malware families. And you'll see here, if I take something like this version of WannaCry, and this file unzipped it to a text file, but as soon as I create it into an executable and just write it to the hard drive without executing it, that alone will trigger an event. So if I take a look at my events within the management console, I'll actually see that there's a malicious event and that there was a file read attempt. So this picked up sort of like a classic AV scenario that a file was written to the hard disk. Now let's take it up a notch, and I'm actually going to turn off the execution prevention policy. Basically, I'm saying turn off all next generation AV features that do whatever they're going to do to stop the execution of a malicious file. I'm going to turn that off. I'm going to rely on the kernel hooks of the other policies. So now, if I go back here and try to run my WannaCry file, we'll actually see that in the task manager, it's now running. And what that means is that I've allowed the execution to happen. However, my data exfiltration and ransomware policies are still in place. So let's execute a few different things here. I'm going to take another malware. I'm going to run that in the background. And another thing I could do is I'll go back and I'll do something a little bit more real world, is I'll take a weaponized document. And I have an example here of a Word document that when I open it, actually has an embedded macro. And this is more realistic scenario. It's kind of like a script-based attack or a fileless attack. Now, when I open this up, what you're going to see is that the end user is presented with this message saying, oh, something went wrong. And click here to enable content. So this is a trick, obviously. What happens, though, when you click that enable content is that you're allowing the macro to run in the background. To the end user, they don't see any difference. They think, uh-oh, well, I guess this didn't work, and they close the document. However, we just give them permission for that macro to run. And we're going to take a look at these events now in the management console. So if we go to the event viewer, we now see a lot more events that have happened. For example, the WannaCry.exe has actually triggered a number of different events. if we take a look at, for example, this event that says there was a file creation, if we dig into that a little bit deeper, we'll actually see that a number of rules from the ransomware prevention module as well as the exfiltration prevention modules were tripped. Things like process hollowing, file encryption, etc. And if we zoom in and take a look at the actual rules that were triggered, we can get description of what the rule is. There's links to the MITRE website for additional information. And this is exactly the type of guided interface that a junior SOC analyst can benefit from. And if I dig into the deeper forensic details of this event, I can see that, in fact, when this process ran, one of the things that this thread did is it tried to drop a file, readme.bitmap, which in fact for this particular malware is the ransom node it was trying to drop to the hard drive, saying that your endpoint has been encrypted. Take a look at some of these other events. You see a number of events for clickme.exe. And I want you to take a look at this particular one that says that it tried to access the services. So when I jump into a forensic view, I can look at these things kind of like in a picture. You see the process flow. So I can see that, look, VSS admin was run, and it tried to access the Windows shadow copy services. Additionally, instead of looking at it as a picture, I can what we call our stacks view, and I can see how every process executed. So vssadmin.exe was the last process that run. But take a look at the command line here. Delete shadows, all of them, quietly. So if your endpoint technology was relying on shadow copies of the Windows operating system, this malware was trying to delete them first before it did anything suspicious. Finally, let's take a look at this PowerShell.exe. And this is actually from that Word document. You'll see here, I'll just zoom in on this picture below. I can see WinWord ran. It called PowerShell. And you get a little bit of details on the PowerShell command. I won't go into the full forensics of it, but you can see it tried to make an external connection to this external IP. So again, that was that script-based attack, just a simple example of the macro that ran called PowerShell and tried to connect externally. Now, EDR, we talk about detection and response. Let's look at the response options. Those response options are things like, do I want to retrieve a copy of memory like I showed you? Do I want to remediate? Like, do I want to delete the file, clean up the registry, terminate the process? Do I want to isolate the endpoint and, in fact, take it right off the network effectively, but allowing nothing to communicate? But what's more interesting, though, is the automated playbooks that can happen on an event. So we take a look at these playbook actions. Yes, we can automatically terminate the process, delete the file, but clean persistent data, which actually cleans up any residual things that were added to the registry, etc., that happened before the process behaved badly. Or maybe we want to automatically isolate the device or move them to a different security group with stricter policies. This means you don't have to run to your EDR console to decide what response you want to do. You can have these responses automated. Next, let's take a look at communication control. And what this is a running list of all the applications on the endpoint that are communicating. So for example, I have a full list of all the applications that are running in my environment. For example, Google Chrome. It's a high reputation, very well-known browser. And we can see all the different versions that are running, who has these versions, where they're communicating to. But here's where it gets interesting, is you'd want to filter on this report and see, okay, what apps are running that have a critical vulnerability. So in this list, I can see Firefox, several different versions. Let's pick on 6501. Now, Firefox 6501, very high reputation out there. It's a browser, but this particular one has a critical vulnerability. In fact, if you look at it, it has several vulnerabilities, right? And clicking on these links will take you to the MITRE website. You can learn more about them, but this is an old version of Firefox. Now, what you can do is you can modify the action. You can say, look, Firefox, specifically Firefox 6501, cannot communicate. So you've effectively put a stop on that application and forcing the end user to upgrade before they can use their Firefox again. What's also new in FortiEDR is the discovery of not only unmanaged endpoints, but also IoT devices. So we can see in your network what IoT devices are there. For example, you can see I have some iPhones in my home network. I have things like my Apple TV, Amazon Alexa that are there, or I can see like my printer. This is all IoT devices that you can't put an agent on, but you can get visibility into it. And expect more things to come in the future in this section. Now, I'll wrap this up by talking about integration. We have integration with FortiGate, FortiSIM, FortiNAC, FortiSandbox, and is continuing to grow as this becomes an integral part of the Fortinet security fabric. Thanks for your time and attention on this very brief overview of FortiEDR. If you'd like to get a deeper dive on this or learn more about it, please contact Fortinet, and we'd be happy to set you up.